Welcome back, dear all. Multiply and divide monomials. Our objective in this lesson is to simplify real number expressions by multiplying and dividing monomials. First, what is a monomial? A monomial is a number, a variable, or a product of a number and one or more variables. Let's see some examples for monomials. For example, 2 to the power of 5. 2 is a number and is raised to a power, and this is called a monomial. Another example, 3x squared. So this is a product of a number and a variable, and this variable is raised to a power 2. This is also called a monomial. So 2 power 5 is a monomial. 3x squared is another monomial. Another example for monomials is 6xy, for example. So this is a product of a number and two variables which are x and y. So 6xy is another monomial. Laws of exponents. How do we multiply monomials? To multiply powers with the same base, we add their exponents. An example for this. 5 power 2 multiplied by 5. First, how do you multiply this? You have 5 here and 5 here. So you have the same base, 5 and 5. So 5 power 2 multiplied by 5 power 1. Why 5 power 1? Because we know that any number with no power, this means it's to the power of 1. So 5 power 1 is the same like 5. So now you have that same base, 5 and 5. So the common base is 5. And we add the exponents according to this rule. We add, to multiply powers with the same base, we add their exponents. So we will add the 2 and the 1 like this. So we put the base, which is the common base, which is 5. We write it once and we add the powers. This will give us 5 powers power 3, or 125 to simplify. Let us check if this is correct or not. Let us do it by another way. 5 power 2 times 5 is 5 times 5, because 5 power 2 means 5 multiplied by itself 2 times, and we have another 5 here. This means it's equal to 5 times 5 times 5, which is equal to 5 power 3, like this one. So we are correct. Another law of exponents is for division. It says that to divide powers with the same base, we subtract their exponents. So again, in multiplication, we add their exponents. In division, we subtract their exponents. An example for this, 4 power 8 over 4 power 2. Look here again, we have the same base, 4 and 4. So the common base is 4. This means that we are going to subtract the powers 8 minus 2, or subtract the exponents. So this means it's 4 power 8 minus 2. So look here again, I will write, instead of writing it 4 2 times, we write it only 1 time and raise to the exponent of 8 minus 2. We subtract the exponents because it is division. Then we simplify. 4 power 8 minus 2 will be 4 power 6, or 4096. Let's have some examples. Simplify using the laws of exponents. Negative 3x squared times 4x power 5. We all remember that this dot means multiplied by. So negative 3x squared times 4x power 5. So the first thing we do is we use the commutative and associative property as follows. We will get the 4 with the negative 3. We multiply them together in this bracket, and in the other bracket we put x squared times x power 5. After that, we look at the common base. Do we have common base here? Yes, we have the x. It's common base, so the common base is x. This means that first we multiply negative 3 times 4 is negative 12. And the common base x raised to the addition, we add the exponents because it is multiplication here. So we add 2 plus 5. So we add the exponents, and this will give us negative 12x power 7. Another example. 2 power 5 times 3 power 5 times 5 power 2, all over 2 power 2 times 3 power 4 times 5. Look here in this one. Do we have only one base that is repeated, or do we have a common base for all of them? Of course not. We have 2, and we have 3, and we have 5. Also in the denominator we have 2 and 3 and 5. So we have 3 different common base. So what we do is we group by common base. So we'll take each group by itself. We'll take the 2 power 5 by itself over 2 power 2. And we'll take 3 power 5 over 3 power 4 by itself. And we'll take 5 power 2 over 5 by itself like this. And we multiply them. Now we apply the rule of exponents, of multiplication, of monomials. So we subtract the exponents in each one because it is division here and here. So the common base here is 2, so it will be 2 power 5 minus 2 equals 3. And here 3 to the power of 5 minus 4 equals 1. And 5 to the power of 2 minus 1 here, which is 1. Now we know that 2 power 3 is equal to 8. This means this is equal to 8 times 3 power 1 is 3 and 5 power 1 is 5. So this will give us, if we simplify, we will get 120. Last example. Hawaii's total shoreline is about 2 power 10 miles long. New Hampshire's shoreline is about 2 power 7 miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? So we are comparing between two numbers, which is 2 power 10 and 2 power 7, and we want to know this one is greater than the other one by how many. So to do this, to find how many times longer, we divide 2 power 10 by 2 power 7. In this, okay, so we put here 2 power 10 over 2 power 7 equals 2 power 10 minus 7, which is equal to, we subtract 10 minus 7 equals 3. This is equal to 2 power 3, and this, of course, it's equal to 8. This means that Hawaii's shoreline is about 2 power 3 or 8 times longer. Hope you understand. Please subscribe and like the video, and to the next video. Bye.